So we've been talking about artificial intelligence. Now we're going to be focusing on robots. Maybe let's start with the question, what is a robot?
So your intuition about what a robot is probably more or less correct. It's an electromechanical device, typically for doing work. Not all of them do look like humans, right? So in an industrial context, they look more like this. So it's essentially an arm bolted to a table that manipulates objects.
And how are robots used in industry, in manufacturing, especially nowadays?
So traditionally, for the last 40-ish, 50-ish, even more years, they have been used to do tasks that require a high degree of precision and where typically forces are large. For instance, building carrosseries for cars, the welding part of it. That's a very typical robotic application today, and we're all familiar with the images from car factories where you have a garden of robots moving about and doing the welding. And the reason you use a robot there is twofold. First of all, these are heavy objects and welding is a tough job, so it makes sense not doing that with humans. They're also more precise. They don't get tired. They can do the, even after the 50th car that is being made, there's the same precise movement. And the other one is you can actually automate this with a robot because the problem is fully understood geometrically, which means you know in advance where the car will be. And then you just position your robot relative to your robot's base where it's bolted to the factory floor and make the same movement in absolute terms every single time. And you just move the world to a point where the robot makes sense, and then out comes a car in the end. And for most of the traditional robotics applications, welding, painting cars, in foundries, taking parts out of machines, putting them into baths, moving them on. These are all fully predictable, fully predetermined movements that are easy to make for a robot.
So what's happening now is something else. AI is kind of coming to robotics, and it's opening up a whole new sort of opportunities, what you can also do with robots in industry. So what is it? What's happening now, and what's the difference? In what way are robots changing?
So the robots themselves don't change that much. You use the same old industrial robots, sometimes a bit smaller, and you use collaborative robots. But it's essentially, a robot is a chain of 6 electric motors and gears, and that doesn't change. What you can do with them if you control them differently, if you don't try to pre-program all the movements, changes a lot. Today we have many applications or tasks in factories that are being done by humans exclusively for the human's ability to hand-eye coordinate their movements, right? There's something that isn't predetermined where you need to actually look into the world and understand what's going on there. How do I deal with this? And these tasks so far weren't suited for robots because they go through the same movements. Now when you need to look and need to react to what's happening in the world, for instance, if you're plugging in cables or do any sort of assembly task where stuff moves about as you manipulate it, then that traditionally couldn't be done. And now with computer vision, taking sort of the next step, Micropsi Industries introducing the next step, that's something that opens up, which means you can go after tasks that so far couldn't be automated, but now can.
Maybe you can explain us what hand-eye coordinational movements are.
So imagine plugging in a cable, say USB. Everybody's done it many times. So without hand-eye coordination, what you would have done in traditional robotics is you do a full 60, right, 3 space dimensions and the rotations, a pose estimation of where your part is, and then you control your robot in a precise movement to angle it in the same fashion and position it, and then you make a single direct linear movement towards that part. And if you're being very precise and your measurements were good, you get it in and you plug it in. That's not what humans do when they plug in a cable, right? We just put the part somewhere in our hand, and then the other hand has the cable, and we somehow jiggle it towards it and approach it. And we make very small but frequent correctional movements as we approach. And as we get closer, this gets easier and easier. We see, okay, now I need to go a little bit to the upwards, and then maybe I need to turn it around because it's USB. And then that's how we do it. And our product, Mirai, is essentially giving that ability to frequently check with the world and correct its movement as it approaches a goal to a robot.
And in industry, you quite often need a kind of smart robot who is able to not do every time the same precise movement, but kind of think with the movement, use sensors. In what kind of industries is this necessary, and why do maybe industry needs algorithms and AI like Micropsi Industries is providing?
That's pretty much everywhere. We as a company, I mean, anywhere where stuff is being assembled, that's where you have these movements. You need to plug something in, you need to clip something together, you need to press something into something, or you need to position a probe at a point where you need to measure something. These are all coordination problems where you need to pick up a visual clue frequently and decide frequently how to make a correctional movement so you go towards it in the desired fashion. So, a way to think about this is, you drive by a factory, there's somebody in there, a human, who does a task, and there is a human there because they do a hand-eye coordinated movement. Typical tasks or typical industries would be, electronics, tools, household appliances, anything that involves cables, essentially. That is, at least, that's where industries that so far haven't done much with robots, maybe in packaging or palletizing at some point, but not in production, where now the opportunity arises to automate, and that's mostly the customers we see in these early days.
And the kind of robots that Micropsi Industries is able to enhance with capabilities, it's the so-called cobots. Maybe you can explain what the difference is between robots and cobots.
We're not actually limited to collaborative robots. It's just typically those types of applications, because today humans do them, lend themselves well to smaller, non-dangerous robots like cobots. So that's the typical machine. We can also work with a 4-meter high welding robot. It works perfectly well. It's the same pattern. The difference is traditional industrial robots were optimized for speed and power and precision. And if you happened as a human to be between the robot and where it wanted to go, it would just hit you and hurt you pretty badly. People have died because of this. So what people did was, at least in Germany, that's quite common. You put a cage around the robot. The moment you open the cage door, the robot stops its movement. Because it's a dangerous and very powerful machine. And what happened in the last 10-ish years or so is that some robot manufacturers, new market entrants, and also traditional players said, okay, let's miniaturize that. And that's build machines that are less dangerous to humans, which means they're easier to be around. So they're not made from cast iron anymore. They're made from aluminium. They move a little slower, so that the impulses, that the combination of mass and speed that they generate, aren't as tough to stop when you hit something. And they're also more sensitive in their joints, so they will feel when they run into something and can stop their movement, which in combination means when it's powered on, when it's operating, as a human, you can be close there without risking your lives.
So robots are taking over jobs that humans are doing right now, or that's possible to be happening quite soon, or with Micropsi Industries it's already possible. But what's happening with the people who then lose their jobs?
Yeah, typically, in most of the applications that we see, they don't actually lose their jobs. They just move on to something less boring. But there's no need dancing around that issue. Of course, we do that because people employ humans right now, and they can achieve higher quality and more consistent quality with robots. And then those people will be laid off. In the long run, at least in Germany right now, finding people to do any sort of work is the problem, not people being out of work and on the streets. So I think the best we can hope for is that people will move on to more interesting jobs. In Germany, we have rather good ways of encouraging this and making this happen, and helping with these transitional processes as that happens. It hasn't been a problem before, right? It's not the first time that certain types of jobs start being automated. In German automotive industries 40 years ago, people were doing the welding, and then robots being installed in those factories and doing the welding now doesn't mean everybody in the German automotive industry has been out of jobs for 40 years. It just means we build better cars, the cars are of better quality, and as a result, more people have jobs. So when you're saying we shouldn't automate with robots because this will put people out of jobs, what you're also saying is we should make worse products at a higher price. And that usually isn't good for everybody's jobs in the end. So, positioning yourself against rationalization and better production is usually not a good thing to do. And, there's enough historic evidence for that, right? German and Japanese automotive industries automated, and guess what? They're still around. And then there's, car makers and national economies that, were opposed to robotization, didn't do it. And guess who runs their factories now?
So there's many jobs that can be taken over by robots and even done much better by robots than by humans. Are there any jobs out there in the world where robots can't compete with human beings?
I mean, today, many, right? I mean, we're sort of pushing. This is not, everybody who founds a company likes to say this is revolutionizing everything. Production is so big that a little step that you take, a little improvement that you make changes a lot, and that's actually enough. We're not saying tomorrow robots will do everything, and that obviously won't be the case for a very long time. And then even if you look at a very long time distance, like 20 years, 30 years, 40 years into the future, is it all machines and all the people are playing the PlayStation or something like that? I don't think so. There are jobs that are about being human to a human that robots just can't do. They will never have the empathy to how it feels to have a human body and climb a tree and fall down and needing consolation. There's one current theme that goes around, at least in the German discourse, which is couldn't we use robots for elder care? And I'm always like, why would we do that? That's the one thing where robotic automation makes no sense at all. Let robots build the cars, and let us take care of our elders. That would be a decent thing to do, wouldn't it?
Aren't robots able to feel empathy, to feel like a human?
For doing that, I mean, robots, you can probably program them to feel true feelings. Different story, but it's possible. Empathy for human, for human grief or anything that happens to us is probably hard. Because for that to work, you need to mentally simulate the other person, which means you need to have shared experience. And then try to imagine perceiving from this mental simulation of the other guy. For this guy, imagining to be me is going to be hard, just as it is hard for me to imagine being that thing out of 6 motors and gears, or as it is for me imagining trying to be a bat, which is also very hard because all our sensory experiences are very different. So empathy for humans, easy for humans, not for robots. Empathy for bats, easy for bats, not for humans.
In our next talk, we're going to be talking about the automation with robots. Maybe you can tell us now already what is automation with robots? Because when we're talking about automation, it's already happening for decades. And what's the difference now? What is automation with robots nowadays?
Yeah.
What's the difference?
So there's a thing called hard automation, in which you build a machine that is very specific to what you're trying to do. So if you're, for instance, making beer or cigarettes, this is the product doesn't change in decades. At least the way you make them doesn't change. So you can build a factory that knows one thing and can do one thing only for a very long time at very high efficiency. And this is hard automation. You just get somebody who knows how to build a beer brewing machine, and then it brews beer forever. With robots, you're more flexible. And you typically use that either because you need to make a very complex movement where you need to reach around somewhere. When you're just doing beer bottles, you can avoid that. They just go in a line and then into a box. But for instance, in traditional industries and foundries, where you need to reach into a tank to pick something up, that's something where you would use a robot versus hard automation. Or you are making something that changes a lot. I mean, the obvious example is, the planet makes around 1 billion smartphones a year. Models change very frequently. This is developing fast. So you don't want to build an iPhone factory that just churns out the same iPhone for 40 years, like you would do with beer. That doesn't work. So this is a typical case where you need a reprogrammable generic machine, which is what a robot really is. Not suited for all tasks, but surprisingly many.